Now in the last lesson we already solved some inequations graphically. What we did was we got everything onto one side, then we graphed y equals the left hand side and y equals the right hand side. Even though our inequation didn't have any y's in it, we sort of put that in because we're letting our two-dimensional knowledge of functions help us to basically solve something that only has one dimension in it or only has x's in it. So it's kind of a trick. We're looking for values of x that make one graph then lie above or below the other, depending on whether we have a less than or a greater than sign. Now, use your knowledge of those basic function types. Is it a cubic curve? Is it a quartic? Does it go from low to high? Is it an upside down one? You should be thinking those things through. And if it's already given to you in factorized form, do not expand it. Factorized form is perfect, and if it's not in factorized form, factorize it. So this one's fairly simple. I can see that if I graph y equals the left-hand side, this is going to be a positive cubic curve because I've got x times x times x as the highest power of x, and all of those are positive, so I know it's going to go from low to high. So a quick sketch tells me that the zeros here, in other words, what we're thinking through is, let's graph this, y equals all of that, and I'm thinking that through in my head, but then I'm saying, well, how would I graph that? Well, it'd be handy to know where the x-intercepts are. How do I do that? I let y equal 0. Now, if I'm letting y equal 0, then effectively writing it out with a y there, just so that I can cross the y out and make it be 0, I can kind of think that through just by looking at this part. Now, all of this part will equal 0 when x is 3, or 4, or negative 1. So I can jot those on a quick sketch. Now, a cubic curve goes from low to high, so I know it must go something like this. I don't really care how high up and down it goes, I just know that's the basic shape. So now I want to know where my cubic curve is larger or above the line y equals 0, which is just the x-axis. Well, that happens here and here. So what values of x are we talking about? The ones in between 1 and 3 and greater than 4. And we don't want the values themselves because it needs to be above the line, not on it. So then I would say that x needs to be between negative 1 and 3, or it needs to be greater than 4. Now I can check my answer by subbing in some number that fits the bill here. A number like 1 would do it. A number like 5 should do it. And sure enough, subbing in a number like, say, 1 or 5 should make this statement true. If it doesn't, you know you've done something wrong. Now this example is much more tricky because it's actually not factorized. So my best bet is to try and factorize it and assume that if I've been asked to solve this, probably it is factorizable or I wouldn't have got it in this exercise. So factorizing perhaps in pairs would help us when we've got 4 terms. If I factorize the first two just to see what happens and see whether that will help me, I can bring x squared up the front and I get x minus 1. But what I really need to bring these together is I need another set of x minus 1 here. And quick inspection tells me that if this is minus 1, then I'll have my minus x and I'll have my plus 1. So that indeed does work. So now I can bring it together and say how many x minus 1s have I got? Well, I've got x squared minus 1 of them. Now, whenever you're factorizing, always look for a common factor you can bring out the front. Always be on the lookout for the difference of 2 squares. And if you've got, any other considerations, like if there's an even number, perhaps I can do 2 pairs, then those sorts of things should be going through your head. Now, am I completely finished here? No, I can see the difference of 2 squares. So let's keep going. I've got x plus 1, x minus 1, multiplied by another x minus 1, and that tells me these two are the same, so that means I have x plus 1 and x minus 1 all squared. Now, how is this better than this? Well, this one is going to be helpful because I can see that either way I've got a cubic curve. I mean, I could tell that way up here when I can see that the highest power of x is cubed. But down here I can see where that double root is, whereas this part here wasn't really showing it to me. It was sort of hidden. So keep going until you've got it down to its lowest factors that you can. Now I can graph y equals the left-hand side. It's a cubic curve that has an intercept at minus 1 and a double root at 1. So it must come up this way, it's a positive one, and then it must turn around but just touch there and not actually go through. Now I can clearly see where is my cubic curve less than or equal to 0? Well, here, this part is less than the line y equals 0, and here it's equal to it. So the two parts of my solution, x can be less than or equal to -1, or x can equal 1. Now let's see if x can actually equal 1. We can sub it in here, here, anywhere we like, really. If x equals 1, then we've got 2 times 0, and that will equal 0. Or up here we could have said we've got 1 minus 1, that's 0, minus 1, that's -1, plus 1, that also equals 0. So we can see that this works. What about a number that is less than -1? Let's try -2. Cube it, you've got -8, minus 4, that's minus 12, minus -2, that's like adding 2, that's minus 10, plus 1 is minus 9, and is that smaller than 0? Yeah, it is. So it makes the statement true, so you can double check your answer at the end.